Welcome back to this lecture. In this chapter, we have discussed the testing hypothesis for population mean, population variance. Today, we are going to discuss testing hypothesis for population proportions. Let's consider what kind of examples are there. Here's a typical example. Will the approval rating of a particular candidate exceed 50%? 50% means he'll be elected, right? Well, we are curious about that. It's a typical example. The unemployment rate was 7% last year. This year, is it increased? Well, that's typical of governmental statistics. 10,000 car accessories are imported by ship, of which 2% were defective by past experience. Well, this time, is there also 2% defective? These are the very practical questions which can be used in our real world. How can you do that? Well, if you understood the two previous lectures, it is very similar. What do you know? Suppose you have a population, okay? And then I'm curious about the population proportion. In order to do that, I collect sample of size n, and then we check the sample proportion. Using this, we can do the estimation of population proportion using this sampling distribution. P hat is approximately, mean is P, variance is P1 minus P divided by N. This is in case of a large sample, okay, and P is greater than 5 or N 1 minus P should be greater than 5. Roughly it is more than 100. Usually they satisfy that. Well, how can you make testing? You plot the distribution of this, means sampling distribution of sample proportion, and it is normal distribution like this, center point P. If your sample proportion is located somewhere else here, then you will accept. Depending alternative hypothesis, if it is located at the corner, either right, left, we'll reject. That's a basic idea. Well, do you remember then? Maybe this is actual distribution of P hat, but in case of normal, we are using some normalization, standardization. I mean, subtract P divided by standard deviation, standard error of that. Here's a formula for that. Okay, there are three kinds of hypotheses, like right tail, P is greater than P0, or less than, or not equal. If it is less than, we have a right tail checking. I mean, if it is far at the right corner, the sample proportion, well, if it is greater than G alpha, if alpha equals 5%, it is 1.645. If it is greater than this value, I mean, the standardized P hat is greater than 1.645, we'll reject. If it is less than minus 1.645, in case of a left tail, we'll reject. Well, in case of a two-sided test, if it belongs to the tail part is 2.5%, You remember what the value it is? That's plus minus 1.96. If it is greater than 1.96 or less than minus 1.96, we'll reject. Okay? You don't need to remember this formula if you understood the sampling distribution of a sample proportion. Let's practice one example. Here's a survey. According to the survey of the last month, approval rating of a particular candidate was 60%. Okay. In order to see whether there is a change in the approval rating, a sample survey of 100 persons shows that 55 people, that means P hat, sample proportion is 55 divided by 100. That's 0.55. You want to test these things. The first thing you have to do is you need to set up hypothesis. What is null hypothesis? It's existing some result that's P equal 60%. What is the alternative hypothesis? There is no saying whether it is greater than or less than. They want to check whether simply it is 60% or not. Like this. Okay? These are the hypotheses. Therefore, well, you need to check this value whether it satisfies normality approximation. Yes, it approximates, if it is greater than 5, you can apply normal approximation. Then standardized p hat, means subtract p0. P0 is 0.6. Plug in 0.6 here will be standard error estimation. If it is greater than, in case of alpha 5%, greater than 1.96 or less than minus 1.96, we'll reject. We check the calculation, it becomes 1.005. I think you would immediately notice that it is inside of 1.96. Therefore, H0 should be accepted. Let's practice this example using EastNU. Are you ready to use this one? Well, in the EastN menu, click EastNU, and then testing hypothesis for proportion. It shows this one. We want to test that whether this is 0.6 or not, like this. Use 5%. What is the sample size? It was 100, right? We collect 100 sample, and sample proportion is 55%. Okay. Click execute button will generate confidence interval, and your calculated value is inside of acceptance region. Therefore, you have to accept. What is the p-value? Maybe in this case, well, this is the sample proportion location, standardized value. You need to calculate this probability. Since it is a two-sided test, you need to multiply by 2. It becomes 30%. That means it's far inside. Okay, these are the testing hypotheses for population proportion. In the next lecture, we'll discuss very interesting testing hypothesis.